Hello, we are doing topic 5, section 2, increasing and decreasing functions. All right, so hopefully you understand now that a derivative is just taking the slopes of all the original function. Okay, so looking at the function at all those points, the original function, finding out the slopes at all those points, and then graphing those slope values. Okay, that's what a derivative is. So here we want to be able to analyze a graph. Okay, a graph of a derivative. All right, so here you've got your, it written in your textbook form. So let me try to put it in layman's terms. Okay, so here we've got a function, x plus 1 times x minus 3. And then what I did first is I graphed it. Okay, so this is what showed up on my graphing calculator. All right. Now, we want to identify the intervals where the original function f is increasing and where f is decreasing. So remember, this is the derivative function. So I'm going to highlight some important ideas. So remember, these values on my graph represent the slopes. Well, what do you know about slopes? Slopes can specifically be either positive or negative, right? That's the importance. So here we have positive values and positive values, and here represents our negative values. Okay, all the negative numbers, right? That's where y is negative. Okay, so if this are positive numbers, that means our slope is positive. So our original function must have a positive slope, which looks like this. And here, for the green part, those are all negative values, so those must be negative slope, so it must look like this. And then this right-hand side is all positive values again, so then the graph changes and goes back up. Now obviously my purple lines here are not the original function, I'm just sketching it, okay? But this is what would happen. Okay, now to write it out, all right, we would use intervals, okay? We would write it out like this. So when x is less than -1, the derivative is positive, and that's an f prime, okay? Again, it's a little hard to see, I don't know what happened to my font there, but it should be f with a little apostrophe. That's our derivative, is positive. So f is increasing on the interval from -infinity to -1. Alright, and then from the interval -1 to 3, that's our x values. The derivative is negative, so f is decreasing, and so on. Okay, now let's continue. So the next part is here we have the diagram of your derivative function. So here I've given it again. So now I want you to evaluate specific values. So let's start with the first problem. Which value is larger, f of 0 or f of 1? Now that's again of our original function. So let's look at our graph. We're going to have at f of 0 is right here, and f of 1 is right here. Well, think about what's happening on our derivative function. All these values are positive. All right, so we've got positive values. So that means our slope is increasing, which means our value should be getting larger, which means 1 needs to be bigger than f of 0. Let's see if we're right. Bam! We are. Alright, let's look at the next one. Okay, so that was this one. We'll do that one in purple. Let's switch to green. Okay, so now we're going to do f of 1 and f of 4. So notice from here to here, these are all negative, which means our values are decreasing. So if our value is getting smaller and smaller, that means f of 4 should be getting smaller. So let's see if we're right. Oh, I said it wrong. Yes, f of 4, f of 4 is smaller, but they were asking for the larger one. So don't do what I just did, all right? Make sure you read the directions on your test. Okay, let's do another one. Okay, which value is larger, f of 4 or f of 5? All right, so hopefully you're realizing here, these are all positive. So, since our values are increasing with a positive slope, that means f of 5 must be bigger. And we've got it. Okay? So now we want to draw a sketch of it. Alright, and that's very similar to what we did before. So this part is all positive, this part is negative slope, and this part is positive. So here's a sketch that Cognitive did. And as you can see, that's what's happening here. We are increasing all the way until 1, decreasing until we get to 4, and increasing after 4, which are the same spots here. Okay? I'm not going to leave those sketches there because I don't want to mess anybody up. Okay. Alright, let's do the next one. So here we've got a word problem. So we've got our derivative function. Alright, we want to find how fast the caffeine level is changing initially. Okay, so what have we done the past two problems? What's the thing we've always looked at? Oh yeah, it's a graph. So why don't we put it in our TI 83s or 84s? Hopefully you can do that. Alright, and you should get something that looks like this. Alright, so we want to describe how fast the caffeine level is changing initially. So that means when x is 0, or sorry, t in this case, because that's time is 0. So at 0, the y value is 578. So that means the slope is 578, so we can write it this way. The initial rate of change of caffeine level is c prime of 0 equals 578. So 578 milligrams per hour. We want to describe the change of caffeine level in the blood. Okay, so again, we just look at the values. From here to here, it's all positive, and from here to here, it's all negative. So initially we are increasing, and then at one point we change to decrease. So you can put it just like this. Since c prime is greater than 0 in that interval, it's going, and it's it's less than 0 in this interval, the caffeine level is first increasing, then decreasing. Okay? Again, hopefully we're following the words there. Next part, how long does it take for the caffeine level to reach its peak? Okay, so think about how it is graphing. So if this is all positive, that means it's increasing. I'm trying to think my color here. Alright, so our graph is increasing, and then it gets to 1, and then it starts decreasing again. Okay, so obviously not the best graph, but you can see that it gets to its high point right here, right before it starts to turn and decrease. And that would be at that 1.19. So it reaches its peak when it stops increasing, so 1.19 hours after the infant. Okay? Alright, this is what you should know by the end of it. Hopefully this makes sense. Make sure to do your assignment linked to this. Ask me in class if you've got any questions.